Hello everyone, good evening. I hope all of you are good and I am also fine. So today I will take another class from physics and from the topics that is dual nature and radiation. Okay, dual nature and radiation of matter, and it is the part number 2 and it will be the part number 2 physics. Okay, so in part number 2 we will study the de Broglie wavelength, this word. So de Broglie wavelength. Okay, so what is de Broglie wavelength? De Broglie wave equation we have to find out from this. So we know that energy E equal to hc by lambda from Planck's quantum theory, and again from Einstein's mass energy relation. What we get? E equal to mc square. That is equation 2. So from that two equation, that is from equation 1 and 2. From equation 1 and 2 we get mc square is equal to hc by lambda, that is c cancel, so mc equal to h by lambda, so lambda equal to h by mc. Okay, or lambda is equal to what? Lambda is equal to h by p, since momentum is equal to mc. So this is the de Broglie wavelength for what? Photon. This is de Broglie wavelength for photon. Okay, now de Broglie wavelength for material particle will be what? If m is mass of material particle and b is the velocity of material particle, therefore de Broglie wavelength for material particle is lambda is equal to h by mb. Okay, lambda is equal to h by mb. So this is known as de Broglie wave equation. This is known as de Broglie wave equation. Okay, got my point? So let me explain again. I just derived what is de Broglie wavelength. We know that from Planck's quantum theory E equal to hc by lambda. This is equation 1, and again from Einstein fertility equation, Einstein mass energy relationship, we know E equal to mc square. So these two equations, if I equal or compare, then we get mc square equal to hc by lambda, then cc will be cancelled out, mc equal to h by lambda, the lambda equal to h by mc. Lambda is equal to mc means momentum, or we can say lambda equal to h by p equal to mc, that is momentum. Okay, so this is known as de Broglie wavelength for photon. And if m is the, according to de Broglie hypothesis, if light particle has wave nature, then material particle should have the wave nature. Okay, so according to him, if m is the mass of the material particle and b is the velocity of the material particle, then the wavelength of the material particle will be lambda equal to h by mb. Okay, so this is known as de Broglie wave equation also. So write it down. So now we will study the de Broglie wavelength of electron when accelerated through a potential difference of v volt. So what is this? Lambda equal to h by rho over 2mk. Here k is kinetic energy of the electron, m is mass of the electron, and lambda is de Broglie wavelength, E is charge of one electron. So we can write lambda equal to h by root over mk, and k is what? We can write also k is EB. Okay, E into B. kgb. So if we put the value of EB here, the lambda will become h by root over 2m EB. And if we put the values of h, if h equal to 6.62 into 10 to the minus 34, m is 9.1 10 to 31, and e is 1.6 into 10 to 19. If we put this value here, and after simplifying, what is become 12.3 by root over b Armstrong. So this is de Broglie wavelength and for potential difference. Okay, if a particle is moving in a potential difference of b volt, then the de Broglie wavelength of the electron will be this one, lambda equal to 12.3 by root over b. Okay, next we will study Compton scattering. Okay, Compton scattering. Next we will study Compton scattering. So Compton scattering formula is or quantum shift. It is Compton scattering is Compton shift. Compton shift. Okay, so Compton shift d lambda equal to h by m0 into c 1 minus cos phi, where phi equal to angle of scattering of x-axis x-ray, and m0 is rest mass of electron, rest mass of electron, and delta lambda is quantum shift. Okay, so it is nothing but the increase in wavelength of photon when it is strike to another object or another electron. Okay, so this one is quantum shift, lambda equal to h by m0 c 1 minus cos phi, angle is angle of scattering of x-ray, and m0 is the rest mass of the electron. So these are the theoretical part of the class. Now we will do some numericals from the previous year sections. Okay, so our first question is like that: the de Broglie wavelength of a tennis ball of mass is given. M is 60 gram, that is 60 into 10 to the power minus 3 kg, with the velocity v equal to 10 meter per second. Okay, so what is de Broglie wavelength? Lambda equal to h by mb. h is 6.63 into 10 to the power minus 34 by m is what? 60 into 10 to the power minus 3 into b is 10. So it will be 6.6 into 10 to the power minus 34 divided by, if we multiply, it will be 10 to the power 2 minus 3. So 6.6. If I cut this, it will be 1.1. So 1.1 into 10 to the power minus 34 divided by 10 to the power minus 1. So it will be 1.1 into 10 to the power minus 33. It will be plus. So it will be 1.1 10 to the minus 33. So which option is correct? Option A is correct. We can write 1 into 10 to the power minus 33 or 10 to the power minus 33. Okay, so which option is correct here, sir? Option A is correct. So it's so simple. This question is came in JEE 2003. Okay, JEE 2003 it's came. So they asked to find out the value of lambda is what? They given the mass of tennis ball is 60, that is I convert in kg, 60 gram, and velocity of the tennis ball is 10 meter per second. So I find out the wavelength of the tennis ball is what? Okay, so let's try next question. So move on the next question. Okay, so our next question is, if the kinetic energy of a free electron is double, then its de Broglie wavelength changes by factor what? So what is given? Kinetic energy is double. So we know that the relation between d equal to wavelength and kinetic energy is root over of 2m k. This is the relation. So h and m is constant. So we can write lambda is proportional to root over k. Is not it? In first case, okay. Therefore, lambda dash is proportional to root over k dash. They given k dash is what? 2k. So the energy of an electron is double. So k dash is 2k. So lambda dash is proportional to root over of 2k. Now come here. Therefore lambda dash by lambda is equal to root over of 2k by root over of k. So lambda dash by lambda is equal to root over of 2k by k. So it will become k cancel. So lambda dash by lambda is equal to root 2. Okay. So lambda dash is equal to root 2 into lambda. So which option is correct here? Option D is correct. Oh, it is inversely proportional. Oh, I'm doing mistake here. Okay, lambda by lambda will be k by 2k. Okay, k by 2k. So it will be 2 and it will be 1 by root 2. So 1 by root 2 lambda. So 1 by root 2 lambda. That is which option is correct? Option C is correct. So option C is the correct answer. Okay. So let me explain it shortly again. Here given, if the kinetic energy of free electron is double, that is, then the d equal to wavelength changes by what factor? That is the ratio. Indirectly they ask the find the ratio. So we know that lambda equal to h by root over mk. So lambda proportional to, since h, 2 and m are constant, so lambda proportional to 1 by root over k. So lambda is proportional to 1 by root over k dash. So k dash is equal to 2k. So lambda dash is equal to 1 by root over 2k. So lambda dash by lambda is what? Root over of k by this is inversely proportional. So 1 by root over k, that is inversely proportional. So root over k by 2k by root over k होगा. Okay. हाँ. So lambda by lambda dash और root over है. So lambda dash will be 1 by root over 2k and lambda will be k. Okay. So I simplified this one. It will become 1 by root over 2. So lambda dash is equal to 1 by root 2 lambda. So option C is the correct answer. Okay, our next question, that is, the question is like that: the de Broglie wavelength of an electron accelerated by a voltage of 50 volt is close to what? We have to find out. So de Broglie wavelength of electron accelerated by a voltage of 50 volt. So here given B is 50. So lambda we have to find out. So we know that lambda equal to 12.3 by root over B Armstrong. So 12.3 by root under B. B is 50. So root over 50 means it will be 5 root 2 Armstrong. Okay. So if I divide 5 by this one, it will become, okay, it will become 12.3 by 5 into 1.41. Okay. I multiply this. First I multiply this is 12.3, and if I multiply this, it will be 5. And this will be 20, 0, and it will become 5 into 6 will 7.05. There is 12.3 by 7 almost. So 12.3 by 7 is 1 point something, 1.7 almost. So 1.7 Armstrong. Okay. So which option is correct? Option D is correct here. Option D is the correct answer. So got my point? What I am trying to say? Say they given B is what? Lambda we have to find out. So we know that lambda equal to, this one is formula, lambda equal to 12.3 by root over B. So if you put this value, and after simplification what becomes 1.7. That is which option is correct? Option D is correct answer. Okay. So here is another interesting questions. That is question number 4. If the kinetic energy of a particle is increased by 16 times, the percentage change in the de Broglie wavelength of the particle is what we have to find out. If the kinetic energy of a particle is increased by 16 times, the percentage change in the de Broglie wavelength of the particle is what we have to find out. So what is given? So we know that the relation between de Broglie wavelength and kinetic energy is h by root over of 2m k. Okay, this one is initial. So final kinetic energy is what? Final kinetic energy k dash will be 16k. So final de Broglie wavelength is what? It will be lambda dash is equal to h by root over of 2m k dash. So lambda dash is equal to h by root over of 2m into 16k. Okay, so if I convert it to 1 by 4 h by root over of 2m k, we can write this one is again lambda, right? This one is again lambda from equation 1. From equation 1 we can write this one is 1 lambda. So percentage change is what? Lambda dash minus 1. The percentage change is what? Lambda dash minus lambda. This change, oh, lambda minus lambda dash, lambda minus lambda dash by lambda into 100. So it will be lambda minus 1 lambda by 4 by lambda. So it will be 3 lambda by 4 by lambda, lambda into 100. Okay, so 3 by 4 into 100%. So it will be cut this one, it will be 25. So 75%. So 75% will be changed. So which option is correct? Option D is the correct. Sorry, option B is the correct answer. Option B is the correct answer. That is, which option is correct? Option B is the correct answer. Okay. This question is came in AIMS 2009. This question is came in AIMS 2009. AIMS 2009. Okay. So let me explain it shortly again. The kinetic energy of a particle is increased by 60 times. The percentage change in the de Broglie wavelength of the particle is what? We have to find out. 4 options is given. I first write the lambda is what? H by root over 2mk. Give you question 1, and k dash is 16k. So final de Broglie wavelength is lambda is equal to h by root over k dash 2mk dash. So k dash is what? 16k. So if I take out 16 as 4 1 by 4, then it will left h by root over 2mk, and here we can put lambda, is not it, from equation 1. So this is decrease. So they ask the change. So change is the percentage change will be final minus initial. Sorry, if initial minus final, because it changes, it decreases. That is 1 by 4. So final minus initial by initial into 100. So I just put all the values lambda dash and simplify. It becomes 75% is scheme. So option B is the correct answer. Got my pen? Option B is the correct answer. So our last question from the topic and from the chapter. Okay, our last question of the lecture and from the topics and also from the chapter. Okay, so if I do this one, after doing these questions, 2 chapter will be completed for modern physics. Okay, so a proton and an alpha particle are accelerated through the same potential difference, the ratio of de Broglie wavelength of proton to the de Broglie wavelength of a alpha particle. So here you have to know mass of alpha particle is 4 times the mass of proton, 4 times the mass of proton, and charge of alpha particle is 2 times of charge of proton. Okay, so we know that de Broglie wavelength is formula h by root over of 2mk. So h by root over 2m what? EB QB. Okay, so lambda is inversely proportional to lambda is equal to what? Lambda p will be h by root over of 2mp QPB, and lambda alpha equal to h by root over of 2m alpha q alpha b. Okay, b is same for both, therefore lambda alpha by lambda p is what? It will be root over of 2m alpha q alpha b by 2m p q p b. This one is cancelled, so m alpha will be 4, m p and q is 2 q p. This is m p, this is q p. This one cancel, it will be 8. So 8 is what? 2 root 2. 8 will be 2 root 2 by 1. So 2 root 2 is to 1. So which option is correct? B number option is correct. This is one interesting questions. Basic knowledge, you have to know this for to solve this type of questions. That is, you have to know the mass of proton is mass of alpha particle is 4 times the mass of proton, and mass of charge of alpha particle is 2 times of the charge of the proton. You have to know this one. So a proton and alpha particle are accelerated through a same potential difference. The potential difference is same, and the ratio of the dBW wavelength of proton to dBW wavelength of alpha particle. But here, see, here nothing is given, just potential difference same, but nothing is given. But from that condition we have to find out the ratio. Okay, and its numerical form. So we know that our mass of alpha is 4 times the mass of proton, and charge of alpha particle is 2 times the charge of proton. So we know that the relation between dBW wavelength is what? Lambda equal to h by root over 2mk, and k is qb, charge into volume, potential difference. So lambda p equal to h by root over of mp qp b, and lambda alpha h by root over m alpha q alpha b. H and b is same. After that I will divide this one, this 2. After dividing, and what becomes? 2 cancel out, bb cancel out, and I just put the below m alpha and q alpha. After simplify, what becomes? Root over 8 by 1. So it will be 2 root 2 by 1. That is 2 root 2 is to 1. Okay. 2 is to 1. So this was for today. Okay, this was for today, and this lecture will helpful for you, I hope, and you just follow this pattern. What type of questions and numericals I did here in the lecture, and use similar types of questions. You do 2 or 3 questions from each concept for more practice. Okay, so you can be able to attend any questions in NEET JEE, WBJEE, and IIT JEE or other engineering entrance also. Okay, so have a nice day. Bye bye and take care.